Hello everybody. We are going to do a demonstration, and the purpose of it is to help you understand relative humidity and how relative humidity changes as you change temperature. So I have different beakers that are all representing different temperatures of air. So I've got my coldest beaker over here and the warmest one over here. So my question for you is, why is it that the warmest beaker is the largest beaker while the coldest one is the smallest one? Well, I hope you remember because I've said it 1,000 times. But the reason is, as you warm air, air expands. Okay? Just like you don't like to be next to people. If you're hot, you want your space, your air does that. Cold air condenses, it gets smaller. It wants to snuggle or it wants to cuddle. So as you increase temperature of air, the container of air gets larger, hence the larger container. As you decrease the temperature of your air, the air gets smaller, hence a smaller container. So I have the different temperatures written down: 100, 70, 50, 40. And in this beaker here, 70 degrees, we have water in it. And sorry, I made the water blue so you could see it, and I wasn't thinking about it being the same color as my shirt. But hopefully you can still see it just fine. So in this beaker, we have the water vapor. So relative humidity is simply saying the percentage of water vapor in the air at the time. So if you're looking at this beaker, then you could say it's about half full. And if it's half full, then that means it is 50% full. So the relative humidity would be 50% because there's 50% of the water in it. Now the question is, what happens if I increase my temperature? Well, if I increase my temperature, the size of my air gets larger because they've expanded, but my water vapor amount stays the same. So if I pour this water vapor into the larger air container, now this beaker is less full. You could say this beaker is about 15% full. So the relative humidity was 50, but as you increase temperature, it went down to 15%. The reason is because your air, as it warmed, got larger because of it spreading out. And so with that, the container was larger, so now this water takes up less room, so it's less full. So hopefully that's clicking. Well, now let's see what happens if we cool our temperatures off even more. So if we have our 50-degree thing, our container of air beaker, and we pour our water vapor into it, now this beaker is 100% full. And so we would say that this is completely saturated. And if you remember from our notes from earlier, we said if air is cooled to the point of saturation, then it has reached its dew point. And so then you can imagine a little droplet of dew, little piece of dew came out onto the grass. So you cooled your air so much that the container got so small that this same amount of water has now filled it up completely. So the relative humidity is 100%, and you've now hit dew point. So then our question becomes, what happens if I cool the air off even more? And that's what the little beaker's for. So if I cool it off even more, it's going to continue to fill, and once it's gotten past this point of saturation, that water vapor has to go somewhere, and so all that water vapor leaks out. And that's what we call precipitation. Okay, so that's when you get your precipitation, because everything is so full, the water vapor has to go somewhere else. So just a quick review again. With relative humidity, that's simply the percentage of water in the air. So if this air is 15% full of water, relative humidity is 15%. If I cool the temperature of the air gets smaller, so therefore it's more full, and relative humidity increases. Okay, so now the air is 50% full, so relative humidity is 50%. So increase in temperature decreases relative humidity because there's more room for water. A decrease in the air temperature increases relative humidity because there's less room for water, so the container becomes more full. So I hope that helps. I hope that is a good visual that you can remember to help you explain this topic, to summarize this topic, or just to remember it for a test. But if not, If you are still struggling with it, I'm sure it has at least clicked for somebody in the classroom, then you can always get that person to teach it back to you. Sometimes they can say it in a better way than I can. But you can also feel free to contact me anytime, shoot me an email, let me know, and I can try to clarify any questions that you may have. Okay, well, I hope you have a wonderful rest of your class, and I will talk to you later.